this kind of example. Okay, so in this example you can see in this example we will see that the system is having two strings. So one string is here and another string is one more. M1, this mass is M2. We have to find relation between the acceleration of the two objects. So what is the system here? We have one mass. Now the another system is hanging like this. Okay. Here again, what we are going to do is we will apply the of and then we can take another distance, suppose from fixed point. We will not take the M2 distance from here. Why I am not taking it from here? Because this pulley itself is mobile. This pulley is moving. So we have to take the distance from some fixed point. So fixed point is this pulley. Upper pulley is fixed. Pulley A, suppose. Pulley A is fixed, but B is moving. So we are taking the distance from pulley A. We have to take the distance from some fixed point. Then we will, after differentiating, we will get the absolute value of velocity and acceleration. Otherwise, if we take with respect to moving object, we will get the relative velocity. Okay. So if we write this as x1 and this as x2, and we will need one more distance. This one also we will need. So this one we are writing as x3. Okay. So this is x3. This is x2. Now we will write length. Suppose for left string, for left string, what we can write is, what is the length? The x1 from here to here, then x3. We can write x1 plus x3 equal to the length of string A, the string which is attached in pulley A. Okay. Now for right string, after differentiating we can convert it. Suppose v1 plus v3 equal to 0 after differentiating. For right string we can write, for right string, if we see right string, this one, the lower string we have what are the total length. So we can see total length. If we see total length, how much we can write? Total length will be, one is this side, that is x2 minus x3. This length is how much? This side, that is x2 minus x3. And how much is this length? So this length will be, we need to write the total distance, total gap between this. So suppose this gap we write, because this gap is going to be constant. So this gap we can take d. Okay. This gap we are taking d. Any length we can take, because these constant lengths are going to be cancelled. That's why we can take it. That will be cancelled. Okay. So this length is x2 minus x3 from pulley B to M2. Now from pulley B to ground, this one up to here, up to ground, this length, this will be how much? D, capital D minus x3. Can we write capital D minus x3? You can see A to B. See, this upper length we are considering negligible. This upper length is negligible. So from upper distance, or we can take it from here only. Okay, from pulley itself. So this is x3 and total is D. So D minus x3 is this length. So now if you write the length of right string, that will be how much? D minus x3. Okay, D minus x3, that is length of this part, and then x2 minus x3. X2 minus x3, that is going to be equal to total length of string B. Now if we solve it, it will be D minus 2x3 plus x2 equal to LB. After differentiation, you are going to get minus 2 V3 plus V2 equal to 0. So this much we are going to get after differentiation. And since we are interested in finding the accelerations or velocity of these two objects, so x3 we are not required, x3 we need not to solve, because x3 is going to be give what? Velocity of pulley B. But we will not write velocity of pulley B, but we are writing the velocity of these masses. So if you want to relate that, we can replace the V3 part from these two equations, equation 1 and 2. Replace V3. So if you replace V3, what we will have? We will have V3 will be minus V1 from here. V3 is minus V1. So you can put in the second equation, so minus 2 and V1 minus V1 and plus V2 equal to 0. So V1 plus V2 equal to 2V1 plus V2 equal to 0, or if you differentiate it again, after differentiation it will become acceleration. So we are going to get like this. Okay, so acceleration of first one means this one, and acceleration of second one are related with this expression. Acceleration of first one and second one are related with this relation, x1 plus x2. So we can write a2 equal to minus 2a1. Okay, so what we can do is, suppose this one is coming down with acceleration a, then this one will go up because of negative sign. So if this is going down, this one will go up with double magnitude, so 2a. So if a is coming down, m1 is coming down, then m2 will go up by acceleration 2a. So in this example, you can see what we have done. We have first related the left string, then we have related the right string, and while doing the whole thing, you have to take care of things, some of the points, that the distance, whatever distance you are writing, that you need to write with respect to some fixed points. So that we have written, and finally we have related a1 and a2. We have replaced the a3 part, and this we have got.